So that was our description about our heuristic algorithms. Mainly, it's a process of doing evaluations, okay? So we keep asking ourselves whether we should downsize, whether we should downsize, whether we should downsize. And whenever we are trying to ask ourselves whether to do downsizing, we need to take an evaluation process back and forth, okay? So mainly we are doing the downsizing decision, but from time to time we need to evaluate whether this downsizing or that downsizing is good. So let's take a look at the pseudocode for facility downsizing process. Maybe that's going to give you a more concrete ideas. So if you are not familiar with pseudocodes, you may just ignore this video, I guess. But if you have some experience about that, then this may be helpful for you. So initially, let's set x to be 0. That means xjk is, xjk, okay, is 0 for all j, for all k, when we just write x is assigned to be 0. So initially, x is 0, and then for each j, we set the highest possible facility level, scale level to be 1. So that means we open each facility at the largest scale level, okay? And then we also set pi star to be f of x. So what's that? F of x is the evaluation of a solution x. So x is something that corresponds to the cost for opening facilities in this way, okay? So it certainly has the construction cost. It also has the customer service cost, and it has the hosting cost. So in a facility, in a function f, we evaluate all these things, okay? And f somehow is estimated according to or implemented according to the idea we used in the previous page, okay? So that's something to do the evaluation, okay? Let's assume this function has been built, and then let's move on. So we will keep iterating until we cannot do improvement anymore. So let's see how to do that. So in each iteration, first, let's use pi bar to denote the current objective value, okay, the current total cost. And then for each facility, let's see whether there is any facility whose downsizing is going to make us better than pi bar. So for each downsizing, we're going to evaluate the total cost. So that k prime be the current scale level of facility j. Now this is something you know. Then we're going to store x, the current solution, to x prime, and then modify x prime to reduce the scale level for facility j by 1. Okay, so that's you do for assigning 1 to facility k prime minus 1, and assigning 0 for facility k prime. And once you do that, now your x prime is a new solution after one option of downsizing. So then you would evaluate this particular downsizing idea. So of course, if your x already have one facility having the lowest possible scale level, then you just skip that one. Okay. So once you do the evaluation, you get pi prime, and once you have that pi prime, you ask whether pi prime is lower than pi bar. If that's the case, then pi prime is a good one. That pi prime has potential to improve the current solution. Then immediately we would update pi bar by pi prime, and also record what's the current optimal solution. It's j with facility scale k prime. Okay, we will keep doing that for each facility. If later we can find one that is even better than the current j star, then we do the updating again. So after this for loop, we will find one facility that has the highest benefit for doing one level of downsizing. Then after these iterations, if there is at least one that can do the improvement, then we indeed invoke that improvement and also update the pi bar to be the next pi star. And then we keep iterating and iterating. So there's only one thing that we need to do to make this happen, is that your f function, when it does the evaluation, it should either returns the total cost, or if the pi prime is actually infeasible, then it may be designed to return infinity or a very huge number. Then it's not going to replace whatever pi bar you have. Then it's in some sense effective. Okay, so we don't aim to train you to write pseudocode in this course. This course is about mathematical modeling. We don't really need to train you about algorithm design or whatever. At least it's not the core for this course. But here, I want to show you the pseudocode for our upper level facility downsizing strategy, just to give you a concrete idea about mainly we are running this process. And from time to time, we need to invoke our lower level evaluation process. And altogether, that's going to give you our heuristic algorithm. That may not be a best one, or that may not be a very good one, but at least now we have a strategy that generates a solution quickly. And somehow that's going to help us make decisions, at least. Somehow, if your optimal solution cannot be obtained, then it's better than nothing, right? Having a heuristic is always good. The only thing remains is that, so first you may want to implement this. You may want to design or write down a pseudocode for your f, or for the evaluation process by yourself. And then the only thing that remains is that we need to evaluate how good the heuristic is. So let's do it in the next video.